Hello everyone, welcome back to our final week before the final. The countdown has begun, so next Monday I'll be posting your final, which will be due the Monday after that. You'll have a week to do it. So it'll be based off of all of the labs. There is a review for it in the final in the course documents. So if you take a look in there, you can see that. And then also, since you'll be doing it online, it's open notes, so it shouldn't be too tough to do. So, for this week, you're going to be having a quiz 7 due. So on 5/4/1159, you'll have quiz 7 due, and you also are going to have this protocol 5.3 plaque assay assignment, which is also going to be due on 5/4. So this is just going to be a step-by-step outline, just going through the methodology of this YouTube video right here. So this is the YouTube video. So you're going to be going through that video. The link is right here. And you're just going to be creating a step-by-step. So step 1, 2, 3, 4, just creating basically an outline describing all the different steps, why she did them, why they're important, what's the purpose of doing this step, all that stuff. And so it's going to be 1/2-inch margins, 12-point font, Times New Roman, so make sure to look at this. Just follow these instructions right here. And if you do have any questions, then feel free to email me, okay? So, for quiz 7, this is going to be based off of your Lab 12 PowerPoint. So, let's take a look at that right now. Okay, so these are our results from last week. If you don't know what these would look like, then take a look at that last PowerPoint. They have some good pictures in there. Okay, so this PowerPoint is all about how do we study other groups of microorganisms. So in the past, we spent a whole lot of time looking at bacteria. That is the microorganism that I spend most of my time with. But we do want to take a look at archaea, fungi, viruses, protozoa. They all do play a role in the environment, and they are very important in their own ways. So, the first one is archaea, which are all going to be single-celled microorganisms. They don't have a nuclei. They're very similar in appearance to bacteria, right? So this would just be a bacillus bacteria, very similar. I don't think you could tell them apart just by looking at them. So, what's different about these is that they do have histone proteins on their chromosomes, which is typically only going to be seen in eukaryotes, and these are going to be prokaryotic cells, right? So they do not have a nuclei. And the next thing is we have our protista, which the first organism inside that group is the protozoa, which are also single-celled microorganisms. They have a nucleated cell, so that's different. But they're going to be exclusively heterotrophic, so they can't create their own food. They have no cell walls, and they're going to be very motile. So since they don't have any cell wall, it allows them to very easily move their cytoplasm around with those pseudopods and everything, like amoebas do. So the next one is algae. So this is our next type of protista. They're single-celled, but then they also can be colonial, where they all kind of live together in a big colony. And then we also have our multicellular microorganisms, so multiple cells make up them. And then these are going to be nucleated cells, and they're going to be photosynthetic autotrophs. So photosynthetic, they get their energy from photons, the sun, and then they're able to create it themselves. So autotrophs, they make it and can utilize it. So then their cell walls are going to be made of glycoproteins and polysaccharides. Okay, and since they're going through photosynthesis, they're going to be very green. Okay, so protista, slime molds. So these are multicellular microorganisms. They have semi-nucleated cells, they're heterotrophic, and their chitin-like compounds are going to be inside their cell walls. So these are, they also have, it's a chitin-like compound, it's not exactly chitin, whereas you'll see in a second that the fungi do have chitin in their cell walls. Okay, so here's a little video of them moving around there to try and find this source of food. So they do have the ability to move, and again, they're going to need to be able to do that because they're heterotrophic. They can't make their own food, and so they can kind of slime around. So these are our slime molds type of protista, okay? So we have our fungi. They're pretty fun. So we have our single-celled, and then they're also going to be multicellular. So as we can see right here, this big mushroom is made up of multiple cells. So these are going to be nucleated, so they have a nucleus. They're heterotrophic decomposers and fermenters, right? So they're going to be breaking down foods and then using that as energy. And they are going to have a chitinous cell wall. So their cell walls have chitin inside of them, as opposed to the slime molds that are just chitin-like. So what you would have been doing is preparing slides and viewing them, but now you'll just have to be looking at this beautiful PowerPoint, which is, okay, not the best. Okay, so the next thing are these viruses. So these are going to be a little bit different than the other ones we've talked about because they are obligate intracellular parasites. So obligate is they have to be, and then intracellular, so they're going to be inside of the cell, and then parasite. So they need to parasitize and enter inside the cell. So depending on what their host is, each virus is going to have a different host. So bacteriophage, such as like a coli phage, that is a bacteriophage is going to, phage is an eat, and then bacterio, so they're going to eat bacteria. And so a coli phage is a virus that is going to eat E. coli, okay? So they're going to parasitize E. coli. And so these are going to, you have the structure on the bottom left, so you can see the capsid head. They have nucleic acid, so that's not going to be a nuclei. It's just going to be the genetic material. It's not an actual nuclei as we have with some of the other microorganisms. It's very rudimentary and simple. They're not going to have any of these machinery like ribosomes and Golgi apparatus, anything like that, because they're going to be using the processes inside of the human cells, or their host cells. They're going to be using that machinery to reproduce themselves. They don't need to have it. So that's why it's necessary for them to parasitize these cells. So you can see they're a little bit different in the fact that they need a host in order to reproduce. And the way that we're going to measure these is that they are going to be plaque-forming units, PFU. So this is the number of viruses capable of lysing host cells. So lysing means to burst. So here they burst out of the cells in some cases. So this is just the number of viruses capable of lysing host cells. Okay, so it's kind of like counting the number of viable cells in a media. Okay, so another thing you would have been practicing is using this micropipette. So how these work is you have this push button on top, and in order to bring in any liquids from the bottom, you have to push it down to the first stop, and then you put it into your liquid, and then you slowly bring this push button up, you release it, and then that's going to pull your liquid into the bottom of this micropipetter. Okay, and then once you want to dispense your liquid, you just enter it into whatever you want to place it into, and then you just push the push button. You push the push button all the way to the first stop, and then you're going to feel some resistance, and then you push it even harder, and it's going to go down a little bit more, and that's going to be the second stop, and that's going to expel the rest of the volume. So you're just pushing air through to basically get rid of anything that's left behind. So there's a few different sizes that we have for pipette mins. There's P20, P200, P1000. So these are just going to be measuring different sizes and volumes. So P20 is for 2 to 20 microliters, then P200 is for 20 to 200 microliters, and so on. So then they have different pipette tips for each pipette. So you can change as you can see, it has a range, 2 to 20 microliters, and on the side there's a volume adjustment knob, and accompanying that there is an indicator that tells you how many microliters you're going to be pipetting. So you just use that to kind of give you an idea of what your volume is going to be, and then you pipette based on that. So if you want to pipette 15 microliters, you get a P20, and then use the volume adjustment knob to set it to 15 microliters. So I'm sure that's something that you'll do in your future classes, and they'll be happy to give you a hands-on demonstration. Unfortunately, we can't. Okay, this is a little bit closer view. Nothing too crazy there. Okay, so this is, like I was saying, reading the volume. So if you look on the left where we have P20, the top number is going to be your tens, the middle one is going to be your ones, and the last one is going to be your tenths. So then if you have 174, that means you have 17.4 microliters. Right, we know that because the P20 only goes between 2 microliters and 20 microliters. So if it's 17.4, we know 17.4. So just the decimal basically moves for each one of these. So now instead of, for the P20, the decimal is in between that second and third square on the bottom. And then for the P200, you have the same three squares, or rectangles, and then the top one is now going to be the hundreds, the middle one's going to be the tens, and the bottom square is going to be ones. So then for that P200, we have a 0 on the top, and then a 5 and a 7. That's going to read 57 microliters. Then for your P1000, so now the decimal is going to be in a different spot. So now the top number is going to be thousands, the middle square is going to be hundreds, and then the very bottom square is going to be tens. And then you don't even have the decimal on there. The decimal is going to be down. So if you had 097, that would read 970 microliters. So unfortunately, you won't be able to test these in person, but I believe one day you will be able to. Okay, so here's the materials. Don't have to worry about these too much. Okay, not going to be on the quiz. Okay, not going to be on the quiz. And, not going to be on the quiz, just a summary. So, again, just be familiar with the use of a pipette, all the different things in this PowerPoint that I want to make sure to know. And, yeah, that's it. So, if you have any questions, feel free to email me. The final's going to be next week. It's crazy. It feels like the last time I saw you was during the midterm. Maybe that was the last time I saw you, so that makes sense. Huh. Well, have a good one. Take it easy. Stay safe. Adios.